Welcome, I'm Carl Tape. The goal here is to gain a better understanding of maps on Earth, to read and interpret global maps, and to understand longitude and latitude. A globe is the best tool for thinking about geography and distances on the surface of the Earth. We will need to unwrap the globe and decide how to display maps of geophysical features such as topography, earthquakes, volcanoes, and more. The globe displays an Earth tilted by 23 degrees with respects to the Earth's orbitable plane around the sun. This tilt is what gives us seasons. It's not a critical aspect of understanding geophysical maps, though. So here's a picture of the Earth, North Pole, South Pole, and we have two angles that are relevant. The latitude is 0 at the equator, plus 90 at the North Pole, minus 90 at the South Pole. Lines of longitude, 0 reference goes through London. It's pretty much an arbitrary choice, but that's what it is. To the east are the positive longitudes, and to the west are the negative longitudes. So these are the way that we can, longitude and latitude tell us a lot, whether you're trying to find someone's house or reading maps. Longitude and latitude tell us where we are on this planet. Another picture of latitudes and longitude. You have the North Pole here, and latitude, these angles, it's an angular measure from the center of the Earth to the North Pole with respect to the equator. So at the equator, it's 0 degrees, but 30 degrees latitude makes a 30-degree angle. 90 degrees would be the poles. That's a 90-degree angle with the equator. That gives you an idea of what these latitude lines are. And for longitude, we have 0 degrees, the prime meridian going through London. And here we have to the east, positive 30, 60, 90. And to the west, these are labeled west and east, but we would call these minus 30, minus 60, minus 90. And so this is really cut through the equator, and imagine these angular lines toward each of these. Almost looks like an orange cut into wedges. So here we have a zoomed in view of the globe, and we can start seeing these longitude lines shown here, latitude lines as well. And one of the point is that a segment of latitude, say here, say 10 degrees latitude, that distance is always the same at any part on the globe. 10-degree latitude, the distance between these two white arrows, at least on the globe, maybe not in this picture, but on the globe, that distance is the same. A 1-degree longitude segment, or in here, say, a 10-degree segment, is not the same distance on the surface. It's longest at the equator right here, this 10-degree distance, and it's 0 at the pole. So here's one segment here. As you go up toward the poles, they get smaller and smaller until they all collapse on each other. So longitude is kind of a tricky way to measure distances, and that's why latitude is a good one for getting a quick idea of a scale on a map. This leads to this connection between a degree latitude and distance, and this will introduce very simple equations to work with, the kind of thing we need for this class. But what is the length of 1 degree latitude on Earth? And the way to do that, the formula is to get that length on the sphere, it's the radius of the sphere times the angle you're interested in. And that angle has to be measured in radians and not degrees. So this shows we have the radius, which is 6,371 kilometers from the Earth. We do need to know that number. And we're multiplying by this angle of 1 degree. We're asking, well, what's the length of 1 degree? And that angle gets multiplied to convert to radians. It's 2 pi divided by 360. So this conversion provides us with a number we can stick into a calculator and we get 111 kilometers. So to get a basic idea of distances on a map with longitude and latitude lines, we can equate 1 degree latitude with 100 kilometers. So 10 degrees latitude is about 10,000 kilometers. And that's a useful rule for looking at maps. So we're going to look at a lot of maps of the Earth, a lot of material, and this is going to be our representation of the Earth. It's a little hard to tell on this white slate, but we will fill some things in. We can see now the continents and the oceans. We can add tick marks, these little tick marks that represent a grid. So this is giving us idea. We need the coordinates of things. This is the longitude, 0, 60, 120, 180. And note that 180 degree longitude is in the middle. Here it is right here. And latitude, there's the equator, 0 cutting across, 30, 60, 90 at the pole. So note that 0 degrees longitude is in the middle. We do not have the east or west labels. Negative longitude is west, positive is east. It's just way simpler that way, in my view, to not have those extra labels. Here's a grid of longitude and latitude lines. So we can use this to find, take the longitude value like the X direction and the latitude value in the Y direction, and we can find locations on Earth. So the latitude lines are straight and horizontal. And here the longitude lines are curved. Those are longitude, and these flat ones here are latitude. Here's a finer grid. This one is every 10 degrees. So every 10 degrees in longitude and every 10 degrees in latitude. So each one of these squares is 10 by 10 degrees. But on the Earth, the area of these squares depends on where you are. So these squares are largest near the equator in terms of area and smallest toward the poles where the longitudes are converging. We can add some political borders and coastlines to get a better picture here of the world. But we don't really need the grid lines to tell us where we are. It's useful enough to have just these tick lines with labels showing us where the grid are. This is pretty close to what you might find online for a map of the world. In fact, here's one from Wikipedia. It doesn't have any tick marks or longitude, latitude lines, but for many purposes, we don't really need to know exactly what longitude and latitudes of points are, but we want to get in the habit of displaying that kind of information because you would have it in, say, a scientific publication. That's what you would see. So here's a map of the world. Again, our view, kind of a more colorful view here. And so here's our map. In this perspective, Alaska is marginalized, literally. It's on the margin and you really can't see the details. It's kind of squeezed and distorted. It turns out that this here is a much more useful perspective for us. The 180 degree longitude is now in the middle. And definitely Alaska is not marginalized as much. It's here pretty much in the center, but it's more useful because of plate tectonics, and we'll see why in a bit. And coastlines and borders are not that relevant for plate tectonics. So, here's coastlines and borders. Well, this is probably giving us a pretty good idea of where things are. We're going to be more interested in other kinds of boundaries. We won't use these grid lines, but we can imagine them there if we need them. In terms of finding places with longitude and latitude, we can think of there being a grid like you might find on graph paper with X and Y coordinates. We will see lots of different things on this map. Takeaway topics: latitude is measured in degrees from minus 90 degrees at the South Pole to 90 degrees at the North Pole with the equator at 0. Longitude is measured in degrees centered on 0, London, and ranging from minus 180 to 180. To get an idea of distances on a map of longitude and latitude grid, find the latitude increment of 1 degree and multiply it by 100 kilometers.